Welcome to CARICOMP Insider, where high-tech facial recognition meets real-world intelligence.
Most people assume the smartest algorithm wins the facial recognition game. But a 99% accurate system can't tell you who someone is if the photo you fed it was blurry, badly lit, or shot from the wrong angle. The technology isn't failing. The data going in is. That matters whether you run investigations for a living or you just unlocked your phone with your face this morning. Every time a facial recognition system makes a match, or misses one, the outcome was shaped long before the algorithm ever ran. It was shaped the moment someone captured that first photo. And if that sounds unsettling, it should, because it means the accuracy we're promised on the box depends on conditions almost nobody talks about. If you've ever wondered why these systems sometimes get it spectacularly wrong, wrongful arrests, mistaken identities, the answer usually isn't a broken algorithm. It's a broken photo. So what actually happens between the camera click and the match result? Every facial recognition system starts with something called enrollment. That's the moment your face is first captured and converted into a reference template, basically a mathematical map of your features stored as a string of numbers. That template becomes the thing every future comparison is measured against. According to NIST Special Publication 800-76-2, this enrollment phase should include liveness checks to make sure you're a real person, image quality checks against international standards for pose and lighting and sharpness, and recapture when the image doesn't meet those standards. When all of that happens correctly, every enrollment is match-ready from day one. When it doesn't, and in practice it often doesn't, the system is working with a corrupted reference from the start. That affects everyone. Investigators get bad lead-s, and ordinary people get misidentified. So how does the actual matching work once you have that template? The system takes your facial features and reduces them to what's called a feature vector, a list of numbers representing the geometry of your face. Then it calculates the mathematical distance between your vector and the one stored in the database, using methods like cosine similarity or Euclidean distance. If that distance falls below a certain threshold, say 0.7 on a scale of 0 to 1, the system calls it a match. But that threshold isn't magic. A human set it, based on how much error is acceptable for that particular use case. A higher threshold means fewer false matches but more missed ones. A lower threshold catches more people but flags more innocent ones too. That trade-off is invisible to most of us. We just see match or no match and assume the machine knows. Now, why does the source photo matter so much in this math? Research published through the National Institutes of Health looked at facial verification from drones at varying distances. What they found is striking. As the face gets farther from the camera, resolution drops, and facial pairs that are actually the same person start to look less alike to the algorithm. Not because the algorithm got dumber, because it had less information to work with. The same system, the same software, the same threshold, applied to images captured under different conditions, produce dramatically different results. According to that research, adaptive verification thresholds tailored to different capture conditions improved accuracy by about 15%. 15%, same algorithm, just smarter handling of the data. For anyone who's ever been told their face didn't match at a border kiosk or a building entrance, this might explain why. The camera angle or the lighting at that moment may have been the real problem. There's another layer most people never consider: metadata. The enrollment database doesn't just store your facial template. It should also store information about how and when that image was captured, along with a trust score for the sensor that took it. Without that context, a match score is just a number floating in space. Was the reference photo taken under controlled lighting by a trained operator? Or was it pulled from a grainy security camera at a gas station? The algorithm treats both the same. But they're not the same. According to NIST specifications, operators at enrollment stations should be trained. Image quality should be tracked over time using automated tools, and data retention policies should support detecting duplicate identities. That's a lot of human process, wrapped around what people think of as a purely technological system. And this is where the biggest misconception lives. People, including experienced professionals, often believe that upgrading to a newer, smarter AI model will automatically boost their match accuracy. It's an understandable belief. Vendors advertise accuracy rates of 99% or higher. But those benchmarks come from tests run on high-quality enrollment data captured under controlled lab conditions. In the real world, professionals are working with driver's license photos, crowded event stills, and angled security footage, conditions that are nowhere near the lab. In some cases, the system itself determines that verification simply isn't possible because the source image is too poor. A 99% accurate engine can't compensate for a photo that fails basic quality thresholds. You wouldn't blame a search engine for not finding a book that was cataloged with a misspelled title and shelved in the wrong section. The search function is fine. The intake process broke the chain. The real performance ceiling in facial recognition isn't the algorithm. It's the enrollment. Every dollar spent on a smarter model is wasted if the photos going in are substandard and the capture conditions are undocumented. So if you take one thing from today, it's this. Facial recognition accuracy is decided at the moment of capture, not the moment of comparison. The quality of the photo, the lighting, the angle, the metadata about how it was taken, that's what determines whether the system gets it right. And improving those inputs can boost results by 15% or more without changing a single line of code. Whether you're building cases or just living with a face that's already in more databases than you realize, the power isn't in the software, it's in the data you give it. Full breakdowns in the show notes.
Now you know something most people in this industry don't. Use it. And when you're ready to put it to work, caracomp.com. We'll see you tomorrow.